you're not going to need any special software to be able to do this. I did put a link in the chat to something called .NET Fiddle, and that's going to let you, if you want to follow along on your side, you can actually write code right in the browser. You can try it out. So no pressure. If you just want to watch and kind of follow along, that's cool too. But if you want to try it out, you don't need to download anything fancy and you'll be able to get going. Okay, so I'm going to go ahead and switch over my video here to the screen share. And then if I learned anything from the last stream, I'm going to try to get zoomed in a little bit more. It doesn't leave a whole lot for us to get on the screen, but um, that should be okay for now, I think. Maybe I'll zoom out to about there. If you have any concerns about how much visibility you have, please just mention in the chat, and I'll try to zoom out or zoom in depending on how it looks. But let's go ahead and dive into it. So in .NET Fiddle, we're going to be set up here. I have the compiler set to be .NET 4.7.2. Don't worry too much about this. The reason I have this selected is actually because this particular website has a bit of an issue when we're going to be putting user input in if I pick some of the other versions. So you don't have to worry about that. But if you're trying it on your side and you're noticing that you're having some issues as we go through this and you're trying it out, you might want to switch your compiler version on the left here to 4.7.2, and hopefully those problems go away. Okay, so what we have on the screen right now is just a really simple program. This is like a shell program for C Sharp, where we have a program class and then we have what's called an entry point that's called main. So you don't have to know too much about that. In later versions of C Sharp, they've actually made this way easier to get started. Literally, the first line of code you write can do something. But right now, we kind of have this extra stuff that you might have questions about, but you don't have to worry because we're going to be writing code in this area right here that I have highlighted. So the code that I have written right now is actually just a bunch of comments, and I wanted to put this on the screen to kind of walk us through what we're going to try to build. So it's going to be a really, really simple calculator. It's just going to take two numbers that we're going to let the user input, and then we're going to basically take those two numbers, add them together, write the answer back out to the console so it'll show up on the screen, and then we're going to have a loop around the whole thing that lets you enter in another two numbers, so on and so forth. And that's going to let us practice a couple things in programming. And I like this example because regardless of the programming language you want to spend more time learning, these concepts are applicable in different programming languages. So we're going to be looking at if statements, where we have branching logic. We're going to be looking at loops, which are another piece of programming that's going to show up basically in any language you go to touch. And then we're also going to have information about the different data types. So we're going to be taking user input that is called a string, so it'll be text, and we're going to have to work with numbers to actually add it together. So with that said, let's go try implementing this code here. So to start, we need to be able to let users enter in two numbers. So what we can do to start is we can actually tell the user, you need to enter your first number. And we can do that with console.writeLine. If you ever go make your first C# program, usually you'll already have something that says console write line with hello world inside of it. And the text that we want to write out to the console goes in between these two double quotes. So we would say enter your first number. So when we do this, I mean, we can go run it right now, and you can see that it's just going to print out enter your first number, and the program's already done. So really simple program right now. We need to do a little bit more. So if WriteLine puts some text onto the screen, how do we get the user input from the user to store in our program? Well, the opposite of WriteLine is going to be ReadLine. So let's go ahead and try that. Console ReadLine, no parameters. And if I run this now, you can see we get this little character here, and we can actually go type something in here. So I could type in 1, 2, 3. and then the program's done. So it's the first part of the calculator trying to get some of this input, but we're not actually doing anything with it. So, okay, if I typed in the number 123, the next thing we want to do is actually be able to take that user input and save it somewhere so that we can use it in our calculator. Because the way the code's written right now, once we get that user input, the program just ends. So we're not actually doing any math yet. That's okay. So the the read line result is something we're going to want to store into a string variable because read line gives us a string back. So we can make a string variable, we'll call it input 1 like this. And again, if I run this and type 123 here, the program still ends, it doesn't do anything. But what you can't see just from running it like this is that at least the number, or the string 123 went into this variable. So that's actually cool. We have that stored in our program now. So every time we go to run this and we type in some input, that's going to get saved into input 1. So what's interesting here is that we have basically two numbers that we want to add together. So if this is how we get one number, how do we get the second one? Well, we can actually just go ahead and copy and paste that code. And then we can say enter your second number. Oops. I have to be able to type properly. And we'll put input 2 here. So a small adjustment, right? We have the input 1 and input 2, and we're writing to the console your first number and second number. Let's go ahead and run the program. So we can say the first number is 111, let's say. And now we can see it's saying enter your second number. Okay, so 222 is our second number. And then the program completes. So at this point, we have stored two numbers in our program when we run it, but we're still not doing anything with it. So when we're working with a calculator, the first thing you might be thinking is, okay, well, we said this calculator is going to add two numbers together. So if we have both numbers stored here, wouldn't we want to just say input 1 plus input 2, and then we could go write that to the console? So we can try that, right? So we could say answer. So we'll go calculate the answer. We'll add them together. And then we're going to write the result. And we can say something like answer. And then I'm going to write another line out that actually just puts the answer. So the first part is just basically to write some extra text that says basically this is going to be the answer, and then we write the actual answer. So what happens when we go and run this now? So we can enter our first number. Great, now we can enter our second number, and then it should add them together. But wait a second, 111 plus 222 should be 333. What happened here? Why did we get 111 and then 222 right after it? Why didn't it add these two numbers together? Well, the reason for that is actually because the input from the console is actually a string. And if you're not familiar with programming, we have basically different data types that we can store our variables as. And a plus operator in the language C# between two strings actually does concatenation. So it will join both strings together. So that's why we see 111, then 222. That's actually not what we want to have happen here. We need to somehow make these numbers so that we can get a number added together and write that to the console. So we can actually fix this by trying to take the input that's a string, right? Input 1 is a string and input 2 is a string. We can go try to convert this into an integer. So what we're not going to start with is any type of error checking for now. Let's assume that in our calculator, when we go to type in numbers, They will be numbers. If we have time at the end of this, we can try to do some error checking. And if we don't have time, that's something that maybe you can try experimenting with on your own time and seeing if you can validate the user input. Okay, so we need to go from string to integer. There's a couple of different ways to do this, but we're actually going to use the parse method. So what we can do is say int number one. So we're going to declare a variable called number one, and the type of it is an integer. Then what we're going to do is say int.parse, and then we're going to pass in input one. Okay, so what this line of code does on line 16, just to highlight it here, what this line is going to do for us is take this string value, it's going to call the parse method on it, which is a built-in method in .NET that we have access to. That's going to take care of taking the string, so the text in our example that was 111, and it's actually going to parse it and see if it's a number and then store it as a number. So, like I said, we're not doing error checking right now. So if you typed the word giraffe as the first number, it will blow up. It will throw an exception. It's not going to work. Your program will crash. So if we have time, we'll come back to that. So that's how we get the first number. Now, if we want to get the second number, it's going to look very similar. I just copy the line. I'm going to paste it. This is also, by the way, one of the most common ways that you get programming bugs is by copying and pasting stuff and then not updating everything accordingly. So I have to be careful here in this live demo, but I'm going to put input 2 here as the number or the input we want to parse and change number 1 to be number 2. Okay, great. So if all goes as planned, we're going to have both of our text inputs. We're going to parse both of those things and have them stored as integers. Now we can go try to add them together. So this line here is wrong. What we actually want is we want to declare an integer, and we're going to say the variable name is answer, and the type of it is an integer, and then we're going to add our numbers together. Okay, so let's go ahead and see how this behaves instead. So before I run this, recall that we had 111 followed by 222, which is not what we wanted. It actually stuck both of those strings together. Not good for a calculator. We need these numbers to actually add. Okay, so how do we do that? Well, let's try running it. Enter your first number, 111. The second number, so far so good. And the answer is 333, which is great. So the difference, if we look back at line 23 and 24, is that your input was a string type, and now we've changed that to be integer based, so we can add integers, and then we have actual math happen instead of adding strings together, which is called concatenation. Okay, great. So we've actually built the very basics of a calculator, but I said we were going to look at loops and we were going to look at if statements. So there's a couple of things that I want to introduce for us that are going to allow us to use loops and if statements. So let's go ahead and try putting a loop in place. So what I'm thinking, there's a bunch of different ways that you can write loops in different languages, and even in C#, there's a handful of different ways. You have something called a for loop, and for loops generally let you count. So you would start at some number, and then you would be able to continue from that number to the next, and then you have some limit that you want to count up to. It's really handy if you have, say, something that you want to, start at one point and get to another. You know how many times that you want to execute the loop. So that's a really good, mechanism for looping on things. There's another type of loop that's called a for each loop, and basically that will allow you to walk through a group of things one at a time And so, as the name suggests, for each one of these things that is in a collection of sorts, then you're able to run some code for each one of those things. In this particular case, I want to use something called a while loop. And a while loop is something that will let you continue running the body of the loop. So all of the code that goes inside of this loop will continue to run while a condition is true. So the way that looks is you would type while, and then your condition would go here. And then all of the stuff that's in here is the part that would loop over and over. So there's a bit of a tricky thing going on here, though, because if you were to do something like this, and we go to run this code, it's actually, don't run this, by the way. This will actually basically run your program for forever and not do anything. It's because there's nothing inside of the loop. It's just a comment. And this condition says, run this loop while true. And the reason this happens is because everything that's between these parentheses, when that, it's called an expression, the part that would go in there, when that expression evaluates to true, and spoiler alert, the word true is always going to evaluate as true, while that expression is true, your loop will keep going. So running something like this isn't going to be a good time. So we're not going to do it quite like this, but I do want to actually use a while true loop. There's a lot of reasons I would recommend against this in general, but for this example, we're going to go with it. So all that I'm going to do is take the rest of our calculator code, right? I'm going to, can I, oh, perfect. I wanted to see if I could press tab and it would indent everything, and it worked. I was scared it might actually erase it, but there we go. So what I've done now, if we look at our code, is it's the same calculator code that we wrote. I didn't change anything. I just moved it over just so it would visually look better. And then I wrapped a loop around the whole thing. So that's kind of cool. So what's going to happen if we run this? So I pressed run, enter your first number, 7. And our second number is 5. This should come out to 12. Good. Okay, my math still works up here. Now, you'll notice that it didn't just finish. Instead, it says enter your first number. So now our calculator is actually something that can run over and over again. So cool. Let me, 9 is the first number, and we'll do 6. So this should come out to 15. Great. So it's not super exciting, but you can see that we have the pieces, the basic fundamental pieces of a calculator going on here. So now what happens when we want our calculator to finish, right? Because it can't finish. It's, as we said, when you have a while true here, your loop is going to run for forever. There is nothing that will let this loop stop running. So currently, our program does not have a way to exit. We can do better than that, so we will. And before I do, what I'm just going to do for fun is show you that our error handling doesn't work. So if I were to say zebra is the first number, what's going to happen? We get this runtime exception, all this nasty printout right here to the console. And this is basically telling us, you can see it tells you the error, right? Input string, zebra in this case, was not in the correct format. So if we look at line 18, this is where we had the parse method. So of course, the word zebra is not a number. It cannot be parsed, so our program actually crashes. Conveniently, when we crashed the program, it stopped running. So now that it's stopped running, let's go ahead and make the necessary changes to this so that we can leave the loop when we want to. There's a couple different ways we can do this. And really, if you're making your own calculator following along, you could change your mind about how you want to do this. I'm just going to show you a simple way, I think. So you could do something like, type exit if you just wanted to exit. I'm going to say if you leave the input blank, though. So if you just press enter instead of entering a number, that's going to exit the calculator for us. So this is where we're going to look at if statements. And what we're able to do is say, if some condition is true, then we're going to have a body of code that follows that will run only when the condition is true. So that will look like this. If input 1 equals, and when we're doing a comparison in C sharp, it's a double equal sign. So if you're new to programming, this might look a little bit weird, but just to explain, the single equal sign, this means that we're taking whatever's on the right side of the equal sign and putting the result into the left side. When you have a double equal sign, what it's doing is going to compare what's on the left and what's on the right. And if that evaluates to being true, so if they are equal, then it's going to, in this case, that'll evaluate to true, and then we'll run the if statement. So I said, just for this example, I want to say if the input's blank, this is going to be us exiting the calculator. So we put our curly braces in here. And how do we exit? Well, we can just go ahead and break out of the loop. Break is a keyword. You can see that it came up in this special blue color here. The break keyword allows us to exit the loop. There's another keyword you could use here called return. Return in this case will also exit the loop, but it will basically, I'm just going to scroll up a little bit higher. If you were to hit this line that says return as your code is running, it will also exit this entire function that we're inside of. So for a particular example, that might be totally fine. You could break out of the loop, or you could return out of the entire function and end your program. In either case, so if I break out of the loop only, right, what it's going to do is say, great, that means I have to jump outside of this loop. And where is the end of the loop? Well, it's right here. So what other code is here? Nothing. So there's nothing there. It will exit the loop and just finish the program on its own anyway. Cool. So this is validating input 1. Like I said, we're going to have an if statement. It's going to check if input 1, compare it with the double equal sign to an empty string. So a double quote followed by just another double quote means that there's nothing between the quotes, so it's empty. Usually I would use some other mechanisms to check for emptiness that are a little bit safer, but for the example here, this is totally fine. And like we've been doing, we can just go ahead and copy and paste this for the other number. Right? So just so I don't mess up, we need to put a 2 here. And what this should let us do is actually, when we run the program, if I said, I want my first number to be 6, and then I said, you know what? I don't want to run the calculator anymore. I could press enter, and you'll see that it is not asking me for another number. It's not printing the answer anywhere either. It's just done. So maybe that's not obvious enough. What we could do is add a little bit more to our calculator. We could say at the very beginning of the calculator, welcome. This calculator, it's surprisingly hard to spell things when you're trying to like code live and also speak. It's kind of bizarre, but this calculator will add 2 numbers together. And I should be more clear. It's not just 2 numbers, 2 integers together. We don't have any error checking right now. So when we run our calculator, it's going to say that at the beginning. And what we could do is at the very end of the calculator, we could say, thanks for using our calculator. Awesome. Okay, so let's go ahead and run this. It's not functionally any different. It's just that it has a welcome message and then a message at the end when the calculator is done running. So I pressed run. You can see welcome. This calculator will add 2 integers together, then enter your first number. Excellent. I want 8. And then I'm going to add 1 to 8. The answer is 9. Great. Now I'm like, okay, well, I only really wanted to add those 2 numbers together. I'm all done here. I can just press enter to exit. And thanks for using our calculator. So cool stuff. I wanted to be able to illustrate to you though, what happens if I change break to return. So I'm going to go ahead and change break here, and I'm going to change it here as well. And I just want you to have a quick look before I run this again. And I'm going to try to repeat the same exercise, but we're going to add 8 and 1 together. And then I'm going to press enter after all of that with an empty input, and we'll see what happens. So remember what this looks like. We have the welcome message. We have the line at the bottom that says, thanks for using the calculator. When I run this, we still get the welcome message. I'm going to add 8. I'm going to add 1. We get 9. Now I'm going to press enter again with no input, so the calculator should exit. And you'll notice that this time, maybe you didn't notice, but if I point it out, you'll see that it did not print this last line here. That's because when we hit these returns, it actually just exits the entire function, like I pointed out before. And actually, what's really cool is, and this is a great part about programming in general, you're generally not writing code into like a program like Notepad or something, or it's not like you're writing code into like Microsoft Word. You have a lot of different tools that can give you information about the code you're writing as you write it. So that's a really powerful thing that we can lean on as programmers. And in this particular case, you'll actually notice that this was smart enough to tell us that this code is unreachable. So in fact, the way that we have this code written, this line of code can never be executed, ever. And it's because it knows that while we have a while true loop here, the only two ways that you could ever get out of this while true loop are this return and this return. And when you run those return statements, it will skip right out of the function and it will never run this. So that's kind of neat. So I'm going to go ahead and put that back to be break. I'm going to change this back to be break. And to be honest with you, at this point, I think we've actually completed most of what we needed to do for the calculator. So I think we still have some time to go try looking at some error checking. I'm going to take a moment to pause, remind people that have joined the stream, because I've seen there's people coming and going, which is great. Feel free at this point, ask questions in the chat. Let me know if you can't hear me at all, because the last live stream I did, people couldn't hear me for a bit. If you have any questions so far about where we're at on here, would love to take a second to try and answer anything for you. And otherwise, I'm going to keep going, but I will periodically try to look over, so don't feel nervous to ask anything. Again, this is totally meant for beginners, so there's no such thing as a dumb question. I can guarantee you if you have a question, someone else is wondering the exact same thing, so nothing to worry about. Okay, so nothing's coming in yet, and I'm going to continue on to the final step that I think should be pretty easy for us to do, but it's all going to center around our input checking. So let's go ahead and just run this. And we saw earlier that because like when I put in simple numbers like, one, like 1, 2, 3, whatever, it all works. When I typed in the word zebra, of course it didn't work because zebra is not a number. And that all basically comes back to this line here. This line here does not have any graceful checking of errors for us. It basically will say, if your string that you're inputting here is not an integer, it will just blow up. It will stop your program. It will throw an exception. If you're not familiar with programming, generally when we have exceptions being thrown, it terminates your whole program. It's not a good feeling, especially when you don't know where it's coming from. But in this particular case, we can actually do something here to make it not throw exceptions. So, for example, it only adds integers together. I showed you typing zebra earlier, but what if I said like 12.5? I want to add 12.5 and the number 6 together. Well, 12.5 is also not an integer. It's a floating point number. And floating point numbers, or double precision floating point numbers, cannot be assigned to integer values. If you're not familiar with some of these things, that's okay. It's just that in C sharp, it's not just a variable type that is number. It's specific types of numbers. So either you're dealing with integers, so whole numbers like 1, 2, 3, no decimal places, or you're dealing with floating point numbers, which allow you to have decimals. Because we're only adding integers, that's not going to fly for us. So there's another method that we can actually use here, and it's not just parse. It's pretty handy. It's called try parse. And what try parse lets us do, I'll give you one guess. It will try to parse the input and actually lets us make a decision without throwing an exception. So if the input itself does not parse to an integer, we have an opportunity to do something else. Now, the way that this method is going to look when we try to ask it to parse, it might look a little bit weird because so far we've looked at some pretty basic things, and some of the next thing that I'm going to write here is maybe going to look a little bit odd, but give me one moment and I'll try to demonstrate. So I'm going to get rid of this because, and I'm not sure if it's going to show us here. Oh, it does. Great. Um, although this is arguably too much stuff. It looks a lot cleaner in the program that I use on my desktop, but the way that this method works for us is that we're actually able to, it doesn't show you properly. If you look at this second part here that says string s and then int result, there's actually a word missing here when we're using .NET Fiddle, and it's the word out. And this is why I was saying this might be a little bit confusing, but I'm going to type this, literally the word out, and then we're going to have int number 1. So you'll notice that I kind of let this settle for a second. It made all the errors go away. This is actually valid code right now. And just to explain what this line of code does, is it will try to parse this input string, and it will output the number into this variable. But it only does this if it works. So something else that this method does is instead of returning, like we had before, instead of returning the number, it outputs it, but it returns a true or a false. So if it could parse it, so if it tried to parse it and it worked, we get the number out, and then it will return a true for us. So we can actually take advantage of if statements here again, and we could say if we tried to parse this, then we do something. So this now reads, if we try to parse input 1, output that result into the number 1 variable, and then it will, this whole part that I have highlighted, will evaluate to true because try to parse succeeded, and then we would go into this if statement. But what I'm going to do here is change this slightly because I'm not necessarily interested in us, like, I'm trying to do some error handling. So when it works, I just want it to keep going. When it doesn't work, I want to do something special. So there's another little thing that we can look at, and it's basically called the not operator. Sounds kind of funny, but we're just going to invert we're going to invert this if statement, and it's just an exclamation mark right at the beginning. Just like that. So when that's in here at the very start, this whole thing is now inverted. So it means when we try to parse and it works, yes, we will get the number 1 filled out with the right integer. But now this part is going to be true, and then this little exclamation mark right in the beginning inverts it and says, nope, it's false. So we've effectively added some error handling on the first input. So what do we want to do when we don't get an integer? And this is a cool part when you're programming stuff because you get to make this decision. We could, like, we didn't want it to throw an exception before. That's what it was doing. It was just ending the program. We could write a message and say, hey, user, that's not an integer, and then we could end the program. We could say, hey, user, that's not an integer, and then we could start over. And maybe that's a good point. We could actually go right back to the top of this loop and say, hey, look, you entered something, that's totally not an integer. We can't add those together. So we're just going to let you try the whole thing again. That's easy enough to do, actually. And it's going to show us one more special keyword. So first thing we're going to do is tell the user, hey, that's not an integer. Okay. And then that just tells them it's not an integer. It doesn't actually prevent anything from happening. It would still not work. So we actually need to use this keyword here. Oops. Continue. There we go. Continue, you can see, is another one of these blue keywords. And what continue does is, if you're thinking about a loop, break was something that got us out of the loop. Continue just sends us back to the top of the loop, which is super handy in this case, right? Because we say, if we try to parse this and the result is not true, right? So if it fails, then we're going to say, hey, that's not an integer. And then we're going to say continue. So it goes right back to the top of the loop. So let's go ahead and do what we did before because we have two inputs. I'm just going to copy and paste it. And I'm going to overwrite the other code we had here before for parsing the second number. Now, I got to pay attention again so I don't make typos, but we need number 2 being output here, and we want to parse input 2. Okay, so based on this code that I've pasted here, it's in both spots. This should be error checking for us. And if I go ahead and run this now, oops, I missed something. Oh no. On line 25. You know what? This might not like it in .NET Fiddle. Let's go ahead. This is always going to be something that happens when you're coding live, so give me one sec. I'm going to try to split this out and do a couple lines here. So I'm going to say bool is valid, and we'll do this. So this is a little bit more verbose now. So it will try to parse input 1. It will, and I actually wonder too, maybe .NET Fiddle doesn't like this all being combined into one line. So I'm going to split that out as well. You can see it's kind of funny that it's not actually, the editor doesn't complain until I go to run it. So something's a little bit fishy there. So let's see if this is happier now. I'm going to go put this in the other spot as well. Of course, this was going to happen when I was demoing it though, right? So that's okay. This is, again, I would not usually recommend just copying and pasting code like this and trying to update it, but let's see what happens. Okay, so there's something about .NET Fiddle not liking the syntax that I used. I'm quite confident that what I typed there actually works in the usual editor that most of us use for developing C# code. It's called Visual Studio. So usually C# developers are not writing code in their browser like this, but we use a program called Visual Studio. That syntax should have been accurate, but anyway, that's okay. If we look at what we have written here, I'll just explain it one more time because I did have to kind of change that on the fly. All that I've done was I declared the variable ahead of time. So this line of code literally doesn't execute anything for us. We're just saying, I want a variable that's called number2 and it's an integer. That's all it does. The next part, this is still the parsing part that we had before, so that hasn't changed. But what I'm doing is assigning whether or not that parse was successful into what's called a Boolean variable. And a Boolean variable, I know it says bool, but like the word is Boolean. It's just short form for it. So a Boolean variable can only be true or false, which is handy. That's exactly what we want. And then you'll notice as well that I kept this exclamation mark in because if you read literally try to read the code like as it's written from like an English perspective, it does say if not is valid, right? So if it's not valid, then go do this. So let's see if it works now. I'm going to put in a number that is valid. So 11 is an integer. Great. So I'm going to scroll up just a little bit. This means that it was able to parse the first number. Otherwise, we would have seen this show up in the console. Because we didn't see this, it's valid. Okay, but what about the second number? Let's try putting zebra back into here. What's going to happen? Hey, look, that's not an integer, and we're right back at the beginning. It's like, I can't add that. So, no, you did the wrong thing. Let's try it all over again. So enter your first number. Well, okay, zebra's not a valid number, but 13.27. How about that? Nope, that's also not an integer. So now we seem pretty protected from having actually valid integers. So let's try 20 and 7. And there we go. We have the answer printed out as 27. So the normal use case of just adding integers still works. We did get the validation for strings that are not integers and then floating point numbers. So those numbers with decimals that are also not integers, that still works. And how did we say we want to exit? Well, if we leave it empty and I press enter, thanks for using our calculator. So that's been about just over 40 minutes. Hopefully, this was a good little intro to writing a little calculator. We got to cover a couple of really fundamental programming concepts that while I'm showing you here in C sharp, I want you to keep this in mind that the concepts here are not strictly for C sharp. These are things that if you were like, hey, I want to go learn Python, I want to go learn JavaScript, surprise, you are going to have loops in all of these languages. They might look a little bit different, but you'll have loops. You're going to have if statements. You're going to have data types. JavaScript is a little bit weird, but anyway, if you go if you go learn JavaScript, maybe you'll go learn TypeScript instead, and then you get some of those types. But anyway, these concepts are applicable across different programming languages, and I hope that as you kind of walk through this with me, the takeaway that you have is not super focused on like, well, why is there a curly brace here? Why is it indented like that? Why isn't it like, I don't know, like doesn't it look like this? That looks terrible. Um, don't do that. It just makes it hard to read. Like why isn't every line starting like this? Like all these little things, like why is there a semicolon at the end of every line? These are things that are specific to C sharp. If you're trying to learn C sharp, it's just going to take practice to really know and understand and make a habit out of putting semicolons at the end of lines. Because believe me, it's a little bit odd as a programmer. In C sharp, at least, semicolons are a character we type all the time. And if you're not a programmer, you probably never find yourself using a semicolon. But the point is that all of these concepts, I hope the takeaway that you got from this is that you can think about how you might apply this to either C sharp if you're learning C sharp or to another programming language if you're trying to learn something else. So that should be it. I will probably try and find a way to save this .NET Fiddle, and then I can put it into the chat actually, and then that way, if you felt like, hey, I got kind of lost, um, you're like watching the recording or something, and you're like trying to pause the video and all that, I should be able to save this, share it to the chat, and then that way, if you're just getting stuck, you can open this up, you can play around with it, and hopefully that will help. So I think that's it for today. Thanks so much for watching. If if you're watching it on a recording, if you have any comments or sorry, questions, please ask them in the comments. Happy to try and answer. And yeah, I think that's it. So thanks again, and we'll try to do another one of these in the future. We'll see you later.